Today we're going to be looking at how to solve systems by elimination and then manipulating the equation so that it says y equals mx plus b so that we can go and graph the same system. We're going to make sure that the solution you get by elimination and by graphing is the same, and then we're going to go over an algebraic check. Okay, so a bunch of stuff just for one question. Alright, so we're going to start with rewriting the question down. So I have 2x plus 3y is equal to 12, and x plus 3y is equal to 9. Okay, so in order to eliminate a variable, we have to create a pair of opposites. I like that this right here already is the same coefficient. I now just need one of them to be negative. Okay, so I'm just going to go and multiply the whole bottom equation by negative 1. Okay, so negative 1 times x gives me negative 1x. Negative 1 times 3 gives me that negative 3y that I want. And we cannot forget negative 1 times 9, so this is equal to negative 9. Now I didn't do anything to the top equation, so I'm going to leave that as 2x plus 3y is equal to 12. Okay, I can now go and combine or add my two equations together. Okay, so I'm going to combine my x's, so 2x minus 1x gives me 1x. I've created my opposites for my y terms, so 3y minus 3y, they're going to eliminate. So then I'm just left with 12 minus 9, which gives me 3. Well, lucky for us, right here, I already have x by itself, so I don't have to do anything else, such as divide by a coefficient, to get x by itself. However, I do need to go back and find y. Okay, so now that I know what x is equal to, I'm going to pick one of the equations. I'm just going to go with the second one because to me it just looks a tad bit easier. So x plus 3y is equal to 9. I'm going to plug in 3 for x. So 3 plus 3y is equal to 9. Subtract 3 from both sides. 3y would be equal to 6. So divide both sides by 3. I know y has to be equal to 2. Okay, so the solution to this system would be 3, 2. Now remember, a solution means that if I was to take my coordinate point, so the x and the y, and go back and plug them into the original two equations, it would satisfy both equations. Now, when I go to graph this system, the two lines should still intersect at 3, 2 because I am graphing the same system. Now, in order to know what you're graphing, I have to be able to see the slope and the y-intercept. Okay, so I'm going to have 2x plus 3y is equal to 12. And so I have to put it in slope-intercept form, which means it needs to look like y equals mx plus b. Okay, so to get that box of y by itself, I'm going to subtract 2x from both sides. So now that's gone. So I have 3y is equal to a constant minus a variable. They're not like terms, so I'm just going to show 12 minus 2x. Okay, I almost have y by itself, so now I'm going to have to go through and divide everything by 3. So I now have y is equal to 12 divided by 3 is 4. And instead of doing 2 divided by 3 and getting 0.6 repeating, I'm just going to leave it as 2/3 x, because then I could easily see my rise over the run. Okay, so before I go and even solve the next equation for y, I'm going to go and graph this line here. Okay, so I'm going to put a point at 0, 4. And then if my slope is negative 2/3, that means I'm going to have to go down 2, but remember you still always go forward 3. Okay, so down 2, forward 3, down 2, forward 3, oops, down 2, forward 3. Okay, now you can reverse it. So up 2, backwards 3, up 2, backwards 3, up 2, backwards 3. Okay, now you're going to use a ruler to connect your points together to make sure it's a perfectly straight line. And because I know I'm going to have to go and draw in another line, we know that we have to label each equation. So I'm going to draw in 2x plus 3y is equal to 12. Alright, let's go and figure out the other one. I'm going to give myself a little bit of room here. Okay, so the next equation, I forgot what it was. X plus 3y is equal to 9. So x plus 3y is equal to 9. Okay, so again, I want the form y equals mx plus b. So I'm going to subtract x. So I have 3y is equal to 9 minus x. Almost have y by itself. So I'm going to divide by 3, divide by 3, divide by 3. So I have y is equal to 9 divided by 3 is 3. Now remember, there's like a 1 right here. Okay, so when I'm doing 1 divided by 3, I'm not going to write it as a decimal. I'm going to leave it as its fraction. So again, I can see the rise over the run. Okay, so I can see that my y-intercept is 3, so I'm going to put a dot at 3. And if the slope is negative 1/3, I'm again going down 1, but still forward 3. Okay, so down 1 over 3, down 1 over 3, down 1 over 3. Let's reverse it. So up 1, backwards 3, up 1, backwards. Okay, so again with your ruler, you are going to make a straight line connecting all of your points. And because it's the second equation, or second graph, I'm going to label it with its equation. So x plus 3y is equal to 9. Now after all that, I still haven't even answered the question. I need to find the solution, which remember is the intersection point, because that point there is a point on both lines. Okay, so this is the coordinate 3, 2, which is what we wanted because that's the solution we had before. I'm going to squeeze in my answer right here. So the solution is 3, 2. Alright, we haven't actually done a check yet. So to check, I'm checking to make sure that my solution satisfies both of the equations. Okay, so I have to jot down both equations. And I'm going to be plugging in 3 for x and 2 for y. So I'm going to have 2 groups of x plus 3 groups of y is equal to 12. Then 1 group of x plus 3 groups of y has to equal 9. Okay, so I think x is 3, so I'm going to plug in 3 for x. And I think y is 2, so I'm going to plug in 2 for y's. And now you're just going to go and simplify each, and hopefully it checks out on either side. Okay, so 2 times 3 is 6, plus 3 times 2 is 6. So lucky for us, 12 equals 12. Okay, let's check this one. I'm going to have 3 plus 3 groups of 2 is 6, so 9 is equal to 9. Okay, so because this point satisfies both equations, I know that it's a solution to the system. I'm able to see that here because it's the intersection of the two lines, and I also was able to determine that using the elimination method. Now, you have this whole model to help you complete pages 25, 26, and on page 27, you are just practicing using your elimination method. Okay, when you are done, you are going to have Mr. Bacon check all 3 pages. Okay, so have them checked. Your homework is page 38. Not being able to graph them is not an excuse. You are going to go back into your notes and you're going to look here for how we graphed those 2 equations even though they're in standard form to begin with. Okay, enjoy!